Okay, let's take another look at our game loop, which is right here. 5D1C, that would be the next we have to look at. All right. Yeah, 4AC3 was the last one. Okay, so 5D1C. Let's go there. All right, this one. Let's break. Well, why does it not let me break? Wait, why does it not let me break here? That's weird. Okay, now it works. That's weird. All right. So we're not even started. So let's start a level first, though. I'm gonna run the level. Okay, and now 5D1C. Okay, it's snaky related. It looks like, even though we're calling something first here. So R is loaded into A. I've never seen anything relevant to the R register before, but that's fine. So to E. I wonder if that's a parameter that comes from the previous function. So let's take a look at the game loop again. Like on water movement, yeah, I mean, I doubt that has something to do with this function, but it is a bit weird. Okay. All right, so let's see what 5D52 does, and that's just below here, that's here. As game started. Oh, that's simply checking whether the game has started, right? Because I'm gonna stop there. It checks it for 0, and yeah, that is has game started. So this probably won't be executed. Maybe it could be the random movement of the snakies. Yeah, because we're looking at direction stuff here. I'm thinking that's going to be the case. So yeah, 5D52 is a simple check because it's only 3 lines here, right? So we return here based on the AND condition. So we're ANDing it with itself. Whether that's 0 or not, has game started. So yeah, that's simple. Let's add that function. 5D25 is has game started, or I guess has round started. Well, I mean, I call the other one round 2. Let's change that, because the terminology is round in the game itself. It's called round, right? So 0x5d52, and then the variable will change that to has a round started. Let's reload that. Okay. So let's look back here now. So this is a conditional call, I think. So let's look that up, because it looks like yeah, this 3 is checked or ANDed with what was in the R register. That's a bit weird. So yeah, I'm going to let it run and break here again. So what do we do? So yeah, now 7 is in here, and we're ANDing that with 3. 7 is of course 3 plus 4, so that should give us a 1. Which a 1 in the okay, no, that does make sense. It's 1 and 2. Yeah, okay. That gives us 3 then, and then we call that if z is set. Okay. It's weird though. Oh, it updates perhaps. So we're loading this into the A register. And then we exit if there are no snakies, which there are, so we shouldn't exit, right? So I'm going to restart the level without starting the round and see if we do get through here. So we're going to disable, run. I'm going to stop, which is F8. Now the round hasn't started yet, so I'm going to break here and see how far we get. So that's now 3A, and that with 3. Oh yeah, so I think this checks. Okay, no, so we check whether there are snakies, right? Which is 3. There are 3 in this level. That makes sense. So this shouldn't return either. It's weird that it checks has round started though, because they don't move. Well, no, it's broken now. I don't know exactly whether they move when the round hasn't started yet. X is the X state, okay, which we save on the stack. Then D026 is in HL. That would be the first snaky data. So we have Y position, X position, direction. Yeah, so it's 3 bytes per snaky. Yeah, which we load in ED and A. So ED and A become Y, X, and direction, I assume. So we load this, we increment, load it in D. So yeah, 1A, 2C, that's the coordinates, Y and X, and then 1A, 2C, and 5 is the direction, which gets loaded in the accumulator. Right, that's 5 now. And then, okay, we go one further. That's for the next loop, I assume. Then we shift right the direction, and we add some stuff. So we're doing a manipulation to get the next one, right? Because we're adding 80 to it. I'm assuming we're going to end up with a new direction here. So yeah, this is probably going to be the code that determines the random facing direction for the snaky, the animation thing. So 248, then we end it with 80, okay, which makes it 88, of course. And then we load A into C, sure. 88, we load IX, which is D113, which is the X state, I think. D113, wrong position here. Yeah, this one, the X state, is loaded into the accumulator. So we saved our calculated direction into the C register for, here. And then we have our X state, checked whether it's 0, which it is because we're not in X state. We do not jump. 5D 4B is, yeah, so we're skipping a couple things here. And then this enemy tile change related is probably just an update tiles function. to update the 4 tiles of the snaky, because I've seen that come back in multiple occasions. So yeah, we're loading our manipulated direction again into the accumulator, which is here now. And then we exchange the E and HL, that's fine. Because HL is going to be given to this function, right? 88 might be, right, this is a tile calculation, I think. So 80, no, not sprites, only tiles. 88 is, oh, it's hex, of course. I don't know that by heart. I mean, it's 8 times 16 plus 8, of course, but yeah, almost time for that. It's 136, which is going to be snaky style. Yeah, that's the top right. So I'm assuming it's about this snaky here. I assume this will turn front facing, but towards the right now in our next iteration. Okay, why did we disappear? So yeah. So it's an update tile thing, and I guess the accumulator has the tile ID, or the first one at least, because they're in sequence, right? So if we give where's my tile viewer? And we did a doc. Okay. So if we give it 88, which is what was it? It was this one here, right? Let's see. This one here, 141. I mean, it should have given 140 though, because these are the 4 tiles needed for to that comprise one entire entity, like one entire sprite. That's a bit weird though. Why would it give the second out of the 4 instead of the first? But yeah. And that's the first parameter, and then HL is going to be the position on screen to C1A. So we can force this now by giving it a different number, right? So let's try to change the tile to a Alma, for example. So let's give it 148. I mean, I'm going to do 145, which is the second out of these 4, right? 145. I'm going to have to convert that 145. That is 91. So let's change that to 91. Can I? I thought I could change the accumulator though. Crap, I can't. That sucks, because I wanted to see whether I could manipulate. That's weird. Also, well, that's unfortunate, but that's fine. So 80 is the base, right? So it's taking the direction, which is 1357, as an addition onto a base tile number, I think, which would be 80. And if we look at 80, I'm better just leave the calculator open. 80 hex would be the base of the snakies, I think. So that's 128, right? 128, I assume. Yeah. So the snakies are all here, and they start at 128. So it's like an offset into this set of tiles. Right, that makes sense. I mean, I could force it by changing this to 144, the base offset. In other words, this one here, the hard-coded 80, if that's changed to decimal 144, then it would show Almas there. I mean, we can try that, of course. But yeah, I think this is just a tile update function, and it needs the starting tile ID in the accumulator in the A register, and then the coordinates in HL. Yeah. So let's change this. Yeah, so this changed the tiles from a dormant goal to an activated goal, but it's just update tiles in general. Update tile at position, and that would be tile ID and then position. Updates 4 tiles based on the first parameter at XY location provided in register HL, and the first parameter is register A. Okay. I did a typo. Okay. And I mean, I can check other occurrences of that function, of course. All right, so we can dip into that one and see what exactly it does. But yes, it's doing 4 times things, right? So 88 plus 0, and then it calls stuff, updating that into onto the video memory or something. That's fine. It's strange that it uses this one too, though. So this is a wrong name too for a variable. Okay, give me more space. So activated skull push block tile top left is a bit of a, I mean, it is related to this, but I'm not exactly sure. This has something to do with movement and pushing around and activated skulls. So yeah, I'm not sure about that. Okay, did we update already? I guess not, right? And then we exchange again, and we are looping. So we're doing this for every snaky on the level. So 3 in this case, and then we just return. So yeah, I think we can safely say that this function does the random animation of the snaky position, like they move around. So I'm gonna give that 5D1C. I'm gonna add that function name 5D1C. That's handle snaky random movement. Well, I mean random facing directions. That's 5D1C. And as a test, we will change this base 80, this one, to make it look like Alma or whatever. So first, let's calculate what the value should be. So we're at the start here. 128 is 80 hex. 80 hex is 128. And we want to start at 144 decimal. So we have to change it to 90. Okay, so let's get our hex editor. First, I'm going to make a fresh copy of our ROM. Okay, now we are going to open this with the hex editor. Okay, now we will look for, I mean, they could have separated this a bit though, like that's a bit, so 90 was the value. Now we're gonna have to look up this, right? So let's take a bit of space before and then include 80 in our search string, right? So let's start at 287s, C680 for FDD. So I'm taking a couple bytes here, looking that up, because we have to find something unique. Like if I can only find this once, and then we're sure that we're in the correct spot, and it's this 80 that we're going to change to 90, right? And now we will load the first level of the hacked ROM, and those three snakies should now look like Alma. Oh, I'm broken. Okay. So I'm gonna disable this one. I'm gonna make sure that it's loading the hacked ROM, which we're doing here, right? This is the hacked ROM. And I'm gonna play the first level. And then as an extra check, I will take away the function and see whether the snakies all stay in place and don't move around randomly. Right, so you saw the initial ones were snakies because that's when the level loads, like the first game loop that runs, then changes them to 90, which we have here now. So it's the hacked ROM now. We have 90 now. And these look, of course, like Almas, but they don't behave. They do behave like the snakies. In other words, they move around, but they are, I can touch them. They still behave like snakies, of course. Right. Right, so that seems to indeed be that function. And then to be extra sure, because now they're moving. Oh, and were they moving when the level wasn't started yet? That's also interesting. So let's start the level over. They only run once, it seems. So there must be an early escape. I don't immediately see where it is kept to the front-facing direction when the level hasn't started yet, but it should be in there somewhere though. Yeah, so let's nop out this function. Let's go back to the game loop. And then this one is this CD1C5D we will remove. And I will see whether the snakies move at all. Or I guess it's going to be, no, let's reset to snakies. So we'll override the hacked ROM, meaning it'll be snakies again. We'll open, so our 90 is now back to 80, as in the starting position of the snaky tiles. And now we will search for this CDCO5C. CDCO5C. Do we have a duplicate? Yes, we do. So we have to make sure we don't. Yeah, so it's called here as well. After you get the first one, simply. Okay, so it's this one, and we'll remove this one, which now is immediately removed. I'm going to reset because I'm not sure if it's going to pick that up. So none of the snakies should move now. Let's start the level. And they do move. That's interesting. So I mean, I guess this function down here can be called too, right? Because there's two here. But that is weird though. Why would that? I haven't figured out yet what the difference is between the stuff at the entry of the game loop, like this stuff, all this stuff, and then there's some stuff we have to look at still. There's like lots of functions here, but then you see a repeat of these functions here, and I don't know yet what the difference is between these two. So we might like jump here at certain points, like 4289, that's not us here. Like I don't see many jumps, so I'm not sure why this is handled again. So, but easy solution. Let's knock out the second one too, right? That should get rid of it. I'm going to reset. Oh no, I did the wrong one. I did the wrong one twice. That's why it wasn't working. I kept this one in. Yeah, that's my mistake. So yeah, I have to overwrite again and look better at what I have to remove. Yeah, of course, it's, well, wait, let's see, let's reload. So the call we have to remove is this one, CD1C5D. I think I did CO5C, yeah. CD1C, 1C5D. Yeah, that was my mistake. Simply, I knocked out this one, and I should have knocked out this one. Yeah, now that one is gone. I'm gonna leave this one in, because apparently it doesn't really matter. I don't know if it will pick up immediately now. Let's see. Yeah, no, I'm going to have to move though, but I'm gonna reload for sure the ROM again though, because I changed it. That's also interesting. Did I make a mistake in my removal here? Don't think so. Why would it go to basic? It's not even picking up the symbols. Oh no, it is. But yeah, not over here. Wait, I think it's confused. Let's apply. That's weird. Why are we going into basic? This is not the game loop either. It's seriously confused. That's weird. ROM image, the hack one, that's fine. Apply. Okay, let's copy it over again. Insert it again. I mean, now it at least recognizes it. That's strange. Okay, I'm going to make that change again. So CD1C5D. CD1C5D, yeah, that's what we had. Save. This one vanishes. Oh, it doesn't recognize it anymore. Why would that be the case? Oh, at least it loads now. Well, I mean, the hash would have changed, right? So do they move now? They do still. That's weird. Okay, so let's knob out the second one too. And now it's gone. I think, is it? No, it's still good, but I'm going to take another look here. Yeah, so they're both gone now. I mean, if they still move around, then our assumption was wrong. Now they don't. So it's apparently this one, the second one, that was also in play. That is weird, because I haven't seen that happen yet, where duplicated functions like egg pushing and stuff still kept on working when I removed the first entry here. But apparently for this snaky AI stuff, it's both that are in play. That's good to know. We'll figure it out eventually what the difference is between the first and the second. So it doesn't really matter that much, because the assumption was correct. They don't move around anymore now. So that was what that function did, for sure. Okay, so we're going back to the regular ROM. Now they should move around again. Yes. And we'll tackle the next function. So back in the game loop, we have, so that was snaky random facing directions. Now 5cc0. Okay, let's go there. 5cc0 has round started. Oh, okay, no, it exits if it hasn't yet. It checks whether it's a bonus level and does a conditional jump based on that. 5cd0 is just here. It checks, okay, so it's an either, if it's a bonus level, then it checks whether the timer is done or whether the door is open if it's not a bonus level, I assume. And then, okay, we do again the trigger timer value of the exit door. 5CE6 is also a bit down here then. I think I need to rename these variables because they're not super clear. Okay, and then we're doing conditional jumps here too. We're skipping this one. Amount of skulls in level. If there are 0 skulls, we return, so it's skull related. Okay. And then we are manipulating skulls. So this might be the mouth opening of activated skulls. And that makes sense because they only move their mouths when the level is finished. In other words, whether the exit door is opened or if it's a bonus level and the timer is running. Yeah, that makes sense. So now, is it only the update? Yeah, it's only the updating of the faces or the sprites. Because we're not doing any manipulation on the position, I think. So this wouldn't be the targeting AI, but just the positioning, the tile updating. Let's see. So yeah, because this is a loop, so it loops over all the amount of skulls in level. So it does this routine an amount of times. And it updates the tile at that position. And let's see, so we have to, what I also think is that it does, it doesn't update the 2 top tiles because that's the top of the skull and those don't change. It's just the bottom, which is the mouth opening. Or maybe they do the eyes light up, I can't remember. at least we don't see a base address to calculate our tile offset from, like we saw with snakies, which is interesting. So snakies started at this and then indexed into the entire snaky array, but skulls are just, you have the top face, then the closed mouth bottom, the activated, right. So this is when they are dormant, right? Well, the two top ones are just dead eyes, black eyes. And then when it activates, it uses the red eyes, which don't change. And then the mouth goes from closed to open, right? So we don't have like an entire sequence of snakies we can index into. So yeah, I'm going to assume, and it's also right above the handle snaky random facing directions function. So I'm going to assume this is simply the update skull, activated skull tile AI stuff. Well, not really AI because it's just updating the texture, right? So 5cc0 is just before this one. Again. So this is handle skull, open, close, mouth, activated skull, open, close, mouth, animation or tiles. And let's then verify that by removing the function. I'm going to disable the breakpoint. We're going to go back to the game loop. And it's this one. Right now it's this one we previously removed. We have to remove now. And I'm going to remove both because I think down here, yeah, it's the same one here. So I'm just going to remove both so we don't have to waste time on, I mean, it doesn't really make a difference now. So yeah, hex editor, nope, wrong one. Okay. We will look for CD C05C. Right, that's this one, activated skull. Yeah, CD C05C. And the next one as well. Save. And restart with, maybe I have a save state in level 2 in the hacked one. No, I didn't do that yet, so let's do that. I have to play the first and the second level a bit, but that's fine. Apply. Okay. Oh, we're broken. Okay. It would be handy to like add the warp function so I can warp 2 rounds, but I have to look at that. So yeah, let's play this one. There are no skulls in here, of course, so we can't really see the result of our modification yet, but it'll just take a second to finish this level. And then, I mean, we do have to play this second level too, because this code only applies when the exit is open, because that's when the skulls start to run and move their mouths. All right. We're in the hacked one, right? Yeah. Let's save the state at the beginning of this second level. This is hack level 2 start. Okay, I'm gonna block them in. And I assume their eyes will turn red, but the mouths won't move, I think. I think that's what's going to happen. And I'm going to save this state again just before the last art framer. Okay, so they do not activate at all, so it looks like it is positioning as well though. Now the question is, are they deadly? I think they are, but yeah, no update is happening at all, nor is there any movement. So let's see if I run into it. Oh no, that's also not the case. So that's weird. So there's more going on here than just the tile updating. That's quite interesting. So that completely like disables their AI. So this is skull activation AI. Okay. Now we will go back to our regular ROM unhacked. And we'll see what happens here in this function. So yeah, we check whether the round has started, whether it's a bonus level, the door is open. Okay. Oh, we return here. I didn't see that. I think I dropped through here. Oh, I didn't see this return. So yeah. Unless we jump out of it somewhere. Yeah, of course, 5CE6 goes beyond. So yeah, this return is obviously if all these if clauses fail, then we just ignore it. So let's see, now it should fail. So we should hit this return, I think, because yeah, the round has started, that's true. So we're not going to break there. It's not a bonus level, so we are going to jump, I think, to this one. No, we're going to... Okay, no, it will return here. I don't think it's going to jump. And the door is not opened yet, so we return. Fine. Okay. Now we're going to do the same thing, but then with the door opened. We have to continue. I'm going to get the hard framer and break again. Now the round has started, of course, and it's not a bonus level, but now the door is opened. So we're not going to return in our in this instruction here. Exit door trigger timer executed. I don't exactly know what I meant with that. D1 F8. Right. So when I open the door, when I pick up the last hard framer, a simple timer, like it's a very low timer, ticks down, and only then this value gets set, I think. And it's the next, yeah, this is a timer value, so that's the next one. Yeah, so this counts down or something, and then for some reason that happens when the last hard framer gets picked up. So it checks for this value. Oh, I think I know what it is. Yeah, we are returning here because if you look, and that's interesting, the skulls do not start to attack you immediately. They wait a couple seconds, I think, or like 1 second or like a couple of frames. So let's see. Wait, so I'm gonna do that again. And we're going to look, so this is at 6 now, right? This is a timer value. So I'm going to load the state again, and we're going to look at this. So it is at 6 now. It counts down to 0, and at the moment it's 0, then they start moving. So yeah, I'm gonna do that again. So they wait a moment. If you look at the skulls, I pick it up, they wait, and then they start moving. That's what this the countdown from 6 to 0 actually means. That's interesting. And then, I mean, they do start, they do change their tiles. Like the sprite is indeed changed appearance. So the red eyes and the opening mouths do appear in those six tick downs, but they don't start moving yet. Right. And is that the previous variable set to 1? So let's look at this one. That's 0, only now it becomes 1, right? So yeah, okay, I'm gonna have to write something here. Yeah, exit or triggered timer executed is actually, oops. So this determines when the mobs can start attacking. In this case, skulls. 6. It's not frames, of course. I mean, it could be because it's going to be frames, I guess, because it takes down one number per loop of the game. Well, the game loop. You get 6 frames. Whilst you get 6 frames where the skulls activate but don't move yet. And that's these two values. So exit or triggered. This is like AI's start countdown. And then exit or trigger AI started. Okay. Right, and the exit or so the countdown has to be 0, 2 before them to start to move. And then we put 6 back into the countdown. We saw that happening, right? Because this counts down to 0, and then when they do start moving, it's 6 now, and they are moving. They are in a moving state now. So we put 6 back in there for next time, I assume. I mean, that's also weird because there's not really a next time until the next round is executed. And then we put 1 into the fact that it has started. So yeah, this is not necessarily something about skulls because we return here, right? So wait, because we're jumping out of this little function here and do other stuff. Is this the decrement of the countdown, perhaps? Because I'm thinking, is it now skull specific or is it general AI stuff, right? So let's check again. We are in a state where the timer is activated or the AI is activated. Let's see. Okay, let's run through again. So yes, round has started, not a bonus level. Door is open. We have started. Do we return? Yes, we do. So it only happens at that one frame where the timer is 0. makes sense. So, okay, let's see what exactly happens then by redoing that. So instead of returning here, we wait until, well, this is going to be triggered every time the counter ticks down, I think. So let's try that. Okay, the counter is 6. Okay, we AND it, meaning we're checking whether it's 0. And if it's, oh, if it's non-zero, then we, yeah, okay, then we start removing the timer, right? Or like counting down the timer. We decrement A, exactly, and we put A into the counter variable. That makes sense. Then we AND it with 1. Okay, so something happens apparently at the 1 tick, not 0, but sure. We load PC. Okay, this is going to be, do we do an update? Yeah, we do an update. So here we update the skulls. So apparently that's only for skulls then. I mean, I don't know of any other, well, yeah, the goals, for example, do also change appearance, right? So they also open their mouths. So that has to be updated too. So there might be a very similar function that checks the same things, like the same timer, but then updates the goals. Yeah. Okay, let's see where we are. Right. So we load BC into A, sure, and then we check whether this checks whether we're at the final frame of the countdown. So we're at 5. We did get or we were at 6, of course, back then. We do not jump. We load B8. Sure, we loop all skulls and we start updating the tiles for each skull. Sure. Yeah, and then we loop, we jump back for the loop. We do that a couple times for each skull on screen and we return. Yeah, so this is indeed the handle skull activation AI for sure. I wonder if the next one is going to be goals, because they have to be activated too. Okay, let's see. Yeah, we gave everything a name here, so that's good. No missing variables, 5D15, okay. For some reason we're skipping the update here, but that's fine. Okay, let's look at the game loop again. Okay, 5B79 is the next. 5B79. Okay, also checks the amount of skulls. It does immediately check. Oh, this is going to be the targeting, I think. The targeting of like the movement of the skulls towards Lolo's position, perhaps. Yeah, it updates the sprite direction. It should load Lolo's position though, because that's going to be dependent on that. So yeah, we check whether the AI can start and whether there are any skulls in the level. Sure. Okay, we are doing, that's interesting too. We're loading a hard-coded value into D1FE. That's interesting. And then loading this, calling this function and checking whether it's 0. Okay, let's see. Well, I mean, I can try to remove it and see if the skulls move at all. I think they will just move their mouths, but stay in position perhaps. So let's try that before we go into the function. We have to go to the game loop. And yeah, 5B79. Let's reset our ROM. And we search for CD795B, which occurs only once. Okay, that's also interesting. So that indeed does not appear here. And CD795B, right? Yeah. Okay. We will load the same level in the hacked ROM. Yes, this one, that's fine. Yeah, we have to start running. I'm going to remove the breakpoint for a moment. And what do they do? Yes, so they... Okay, it's completely confused now. So it's not just movement. Apparently there is movement, but in a very weird spot. No, okay, it's very, very confused now. I would have assumed they just stood in their place, though. They didn't move at all. So yeah, we'll have to look into the function and see what is happening. Let's load the normal one. We have to go to 5B79. And yeah, it's this point that interests us. Okay, we can pick it up. Right, so it takes down. It only starts when they are actually starting to move. So we load 2 into D1FE. That's also interesting. D1FE is getting 2 in it. I'm going to see if I can mess with that value. Oh, that's only during this loop, perhaps. That's interesting. Wait, D1F, no, it's this one. So for some reason, yeah, this is always overwritten. Maybe we'll figure out what that means. But yeah, it's being loaded 2 in here. A hard-coded value, and that's interesting. So let's look what 5C15 does. Amount of skulls in level. Okay, this returns here, and we don't jump. Yeah, we do jump away. No, that's just here. Fine. So that's a small function. Okay, so we load the amount of skulls. We load the pointers to skull 2. No, why? Oh, does it? Why would it load skull 2? Okay, we have 2 skulls in the level. We put that in the B register. We load skull 2 position. That's D048. Why not start at skull 1 though? Is there an AI difference between the first and the second skull? That's weird. Okay, so we load the Y position, so the XY position actually, because it's in HL, it's like the base pointer. Oh, we're doing some decrements here. And we load the X date, because then you don't have to move, right? We load D1FA, also something we don't know about. Oh, that looks like a position, does it? 1, 3, 4. Okay, we load D1FA and we add it with 1. 86 is 0 because 6 is 2 and 4. It's an even number, right? And then we jump to 5, so we skip this incrementing thing. If it is, we do not now decrement IY. IY being D11E. Oh, now we go to skull 1. That is weird. Okay. We increment B, which is the amount of skulls in the level. We decrement HL, which is D048. So we now go to, we decrement 3 times, so we are at the start of the 3 bytes that represent skull 1. And we shift right B. And now we're at 1. I think they're simply doing, well, no, because we return immediately here. Like we're not manipulating the first skull at all. Yeah, so this function doesn't have any side effects, right? We only load. No, we don't load anything into memory, right? We're not writing something. That's weird. I'm not sure what that does exactly. Like it only manipulates the second skull. And we return if it's 0. Okay, is that the case? It looks, no, it's not. Okay. Oh, it returns if the Z flag is set, which it isn't. Okay, BC, HL, IY, sure, we'll save some values. IY, D11D. Is the X state. Okay, we're checking whether it's in X state. Okay. We're handling this sprite. So yeah, we have some memory reserved for the sprite we're handling at the moment, or the AI, the mob we're handling at D011. Yeah, so these couple bytes are like a working area, I think. And then we're loading HL into that, which is D2C08, which is the position of the first skull, I think. And we return. Okay, so right, so this loads a position in the current AI sprite. Let's see what the arguments were here. Okay, we're exchanging HL and DE, so DE had our values. Perhaps they did come from this function. But yeah, 4363. So it loads the value of HL into IY and saves HL, which was the address of which was in IY, is saved into the current AI sprite Y. So it writes down the XY coordinates in the currently handled AI sprite. The sprite is a wrong word here, though. I shouldn't name that sprite. Yeah, so the AI sprite slot gets all the mobs copied into it and processed. So that's what we're doing now, right? So this function literally copies the position of the thing we're handling into this slot. So I'm just going to call it AI slot. Current AI slot, Y and X, and then this function just 4363. Okay, it's just after this one, of course. So loads. Load IY pointer chords into AI slot. Let's double check by breaking here again. So or moving. Let's move here again. So we're here. IY is D048, which is this one, which is skull 2. Y and X is 0428, which gets copied into here. 0428 should appear here if we skip this function. 0428. Okay, yeah, that's what that one does. And then we exchange again. That's fine. 4391. Let's see what that one does. Okay. So HL gets D048. That's again our working. Well, no, it's like the skull we're actually looking at again. Oh, we're probably going to copy something else, perhaps. Let's see. Yeah, very small function again. So we load IY plus 2, and we are putting that in the current AI slot direction. Yeah. So this copies, like it's the same thing, right? 4391. So the other ones were up here, yes. We'll probably encounter these ones too. 4391. Which is load well, it's IY pointer again, of course. IY pointer direction into AI slot, but that should be singular. Where are we? Yeah, so we were here. So 7 gets copied here, I think. Yep, exactly. And then 5888, that's going to be X state perhaps. Let's see. Let's go in there. 5888. Oh, that does appear to do more. Okay, 5888 is the thing we're looking at. We're checking whether it's a bonus level. that's not going to be the case. So we probably do not jump. Yeah, we do not jump. Okay, we'll save some values, and then again an unknown memory location, D208, which is this one, is 1. We're loading our current Y position, well, XY position into HL, sure. That's 2804, which is indeed these two guys here. And now, so this is targeting. This must be targeting because we are loading Lolo's position Y now into DE. So I think, yeah, this is skull targeting. Okay. So yeah, Lolo's position Y is loaded. Then we load D into A, sure. Yeah, so we're doing some math to determine what the plan of attack is here, how to move next to get closer to Lolo. So IX is D208, which would be, oh, these are these guys here. These might be target directions we have to take. Not sure exactly what that means, because like it's hidden in the math here, right? So IX is indeed our little 3 values here, or maybe 4. And it's doing stuff with this. So it's taken the first and the third. Oh, it's putting 2 in there. Okay. Right. Wait. So IX plus 3, 208. Oh yeah, it's 4 bytes. Okay, so it's 4 bytes. Okay, this is a bit more complicated, but yeah, I think this is the targeting for the skulls. Right, we load. Okay. We increase that, increase the third one. T208 again, sure. T20B, that's further down. Oh, that's a 4th, okay. Oh, and that's going to be the result, I think, perhaps, for this skull. Well, it's 0 though. Okay, this is interesting but complex. So we jumped up all the way here, right? So I'm going to call 5888 skull targeting AI. And we'll try disable that to see if we can actually make that happen. So instead of canceling the entire function, let's just block out this specific one, and then I want to get these 4 bytes and name. Yeah, it was this one, right? D208. Yeah. Which would be skull targeting AI unknown 1. D208 correct, right? D09 A and B. Okay. Yeah, because we're indexing off this base pointer, we're adding 1, 3, 1, 3, 1, 0, 2 and stuff. I mean, there's 4, so there's going to be like 4 cardinal directions or something that it's doing something with. And then at the end, we will return or override it somewhere in the current slot direction. And we have attacking scroll direction as well. So yeah, I'm gonna try to remove that function by, let's see where we are. Okay, we started over, that's fine. I have to just look for the call to 5888, I think it was. Where are we? Yeah, this one, 5888. So this call here, if we remove that one, let's see what happens. It might break more things though, because D20C, what's the largest one? This one. Oh yeah, that's then the next one. Yeah, so D20C is then put in the current slot direction. Okay, and we're calling that something with that too. So this might also be skull targeting related. Okay, let me get, did I already overwrite it? Yes, I think I did. And let's get the hex editor. Now let's look for CD9143, CD8858. Only once, that's good. And what we want is CD8858. I don't think that returns anything though, because we're already overwriting IX, B, and A being the return value, I assume. So CD8858 is now gone. And now we will load our, no, so let's disable our breakpoints. Is the 5BA2 that's important. Let's load our second level before the hard framers of the hacked version. Okay. Yeah, and they stay in their place, and they are dangerous though, so I will die, I think, if I touch them, but I don't move them anymore. Oh no, okay, so the collision is also done in that function then, I guess. But yeah, they don't move anymore. Okay. Let's go back to the game loop. Okay, so well, we had the activation AI. I don't know if we have to look to other stuff here. 5C0, I think it was. Yes. Where is the targeting call? So we're updating tiles. Wait, am I looking at the wrong one? Yes, I am. Was it 5B79? I think it was, right. 5B79. Yeah, this one was the one we were looking at. Yeah, this one is the knocked out one. I'm going to go back to the normal ROM. Come on. Yeah, so this is targeting, but it does more than just target. I mean, it's targeting and collision apparently. I want to see what this does though after the targeting, because D20C is also an interesting one. So they are at 3. I think we're handling the first skull here, and 3 would be up, I think. Where do I have my directions? Yeah, 3 is right. But fine, let's see. So we're loading lots of stuff. IX is D20C, which is this one. Okay, of course, yeah. We are writing that in our current slot direction. Okay, which is all the way up here, right? That's this 5 is going to be made a 3. Yes. And then we load the same thing in here. So these are 3. Okay, what is this one? Attacking skull direction. So these are all skull AI related as well. Okay, so it's loading this one in that variable too. Wait, I missed one. Oh, it was IY, D045. No, I was wrong, looking at the wrong I register. D045 is the actual direction of the skull here. 45 is this one. Wait, what? D045? Wait, IY, right? Or, oh, +2. Okay, so it became this one. Yeah, okay, sure. And then we call this function, which does what? Oh, is this the collision check? I think it might be. So I think it's checking, yeah, I think it's checking low loss positions for collision against everything that's put in the AI slot, in the like, what are we currently handling AI slot here, and it writes the value into collision 1 and then does its thing, right? Okay, so we are at 627C. There's like 4 functions in there. I hope they are small, like just fetching stuff. So let's see. We're loading the pointer to our AI slot in HL. Well, no, the value of the first coordinates, then X and Y, I guess. Yes. And we're pushing that on the stack. Let's see what this one does. C2CA. Relatively small, but calls another function. That sucks. What does this one do? And it calls another function. That sucks though. That's getting quite deep now. Oh, that's also weird. It calls and then it's the next line, sure. It calls a direction in A. And then yet another one. That's like a trampoline thing, like a switch statement. Oh, depending on the directions. Okay. So it does something depending on directions, sure. Okay, we're incrementing, sure. And the value of, and return. Okay, sure. And that's the same function, I think. Yeah. So it does something. We're comparing it with 1, 3, 5, and 7, which are the four cardinal directions. And we're jumping conditionally, right? So to 656C. This one is for 1. This one is for 3. But we're doing the same thing, I think. So we're increasing HL and increasing that value. And for 6C, we're decrementing. Okay. Right. 656C So let's write that down. So if direction equals 1, what do we do? So we jump to, right, that makes sense, right? Let's look at what, so our direction is currently 3. So our A is 3. So let's do that one first. Okay, so that doesn't happen. This does happen. 6566. So we increase HL. So DO11 is our starting position. DO11. Okay, that's our Y position. So that means AI Y plus plus. Well, no, well, yeah, we do. So we load, we increase HL, which means we're going to, no, it's X position though. So we start at DO11 and then we increase it to the X position and we're increasing the value of that. So this is X. X position gets incremented and we decrement HL. Okay, we return, we restore our pointer to the first thing here. Okay. I mean, it's gonna leave now though. Right, but let's see what, let's just look what one would do, right? And I'm going to, instead of 1, 3, I'm gonna put the actual directions so we don't forget. So 1 is up, okay. So this is up, and this is right. So if the direction is right, we increase the, which makes sense. That's absolutely makes sense. We are increasing our X value. I mean, I'm assuming then up is going to decrease Y. So let's see. So we jump to 656C, which is this one. We are decrementing the value in HL, which points to the Y value. Yeah. So this is AI Y minus minus, and then for 5, I mean, it's pretty obvious what it does then, I guess. 5 meaning down. It's going to increment Y, certainly. 656A, increment the first one, which is Y plus plus. Okay, and then, I mean, let's be certain, but it's going to be 7 is left, so it's going to decrement X. Left is 656E, which is this one. Increment HL, wait, left is X, of course, X minus minus. So we go to, wait, which one was it, 656E? Yeah, so we increment HL to go to the X position, we decrement it, and we restore our position. So this is a apply direction thing, right? Apply direction to AI slot. Yeah, that's pretty easy. I don't know what the entry point of that function was. Did we write it down? 627C? No, that's not it. I'll have to start again. So it was perhaps in this one. Crap, now I forgot where we were. Okay, this one was, yeah, okay. 6555, so it's this one, right? Wait. So that one was the next one, and then 6555, I think. Yeah, 6555. Apply direction to AI slot position. No, direction. updates x and y chords of AI slot x and y depending on direction given. Okay. And that returns. So this little function where we jumped into was 6. So yeah, I mean, this is obvious, right? So it's 627C, I think. No, it wasn't. I can't remember. 62EB. Oh yeah, that's the one. Sure, that's the one. Yeah, it's this call. So let's update. So 6555 should change in the name we just gave it. Yeah. Did we look at 62EB though? Oh yeah, no, that's okay. Again, that's the one just after this here. That's irrelevant. E8. I mean, that just prepares, right? So, and I'm current select that prepares the apply function parameters. Sure. It does this call though. 62E5. Oh no, that's this one. It's weird that those aren't jumps, but actually calls, because that influences the stack, right? It pops the PC target from the stack if you return. And does this now, we have 3 in our thing, which was the direction that the result of this function is apparently the new direction of the enemy. And we are comparing that with 1 and 7, though 1 and 7 being up and down. 1 and 7 is up and left. That's interesting. 627C is where we were at. That's what we were looking at. And then 658F. So 1C16. We are pushing, that's fine. Loading 0 into D. Loading H, 8, 2016. That's our XY position of the thing, yeah, okay. Of the AI slot. We're loading H into E, sure. That's the Y coordinate, shift right. So divide by 2, I guess. Load 0 into H, okay. And then we're adding it 4 times. Okay. Yeah, this is going to be offsetting into the tile array, I think. And then we're adding our right shifted thing, okay. And we're adding 1800, that's also interesting. Or no, we're loading DE and we're adding that to HL. So yeah, we have 1970 now. That's weird though, 1970. this might be a lookup because we are looking something up in the tile map. So let's see. Okay, again the 1800. That's 3, sure. What was SBC again? I have to look that one up. This one, SBC. SBC of what? HL and DE. Where are we? HL and DE. Well, that's weird. Okay. Subtracts DE and the carry flag from HL. Okay, so we're just subtracting DE from HL. Okay, yeah, that's the reverse. Okay, so we are in the previous function we were adding them together, and now we're subtracting them again with the 1800 stuff. So yeah, that's our 170 again. And 170, is that something? Well, that's 368 though. We're loading the tile map into DE. Sure. That's C81E, that's just a pointer, and we're adding them together. So it's position 170. Okay. And we put DE. Okay, so DE is now 7476, which is, I think, I mean, it's not going to be anything, right? Because we don't have a collision right now. Or is it a wall? Let's see. $116 and $118. Oh, it's a block. Yeah. So this guy is pushing to that block. Yes. Yes. Right. So this is indeed the collision detection within the AI, I guess. All right. I mean, this function is quite complicated. Right, let's check. Where are we? So we do 2 more calls here. Okay. Let's see what this one is. We're calling something, loading 300 into DE, or we're adding 2HL, which is 1970, adding 0300 here. But let's see what this one calls. Again with the 1800, looking it up in the tile map. Okay. We're subtracting again our 170, loading the tile map, adding that to the tile map. $7476 is added 0300. Okay. Well, no, it's overwritten. Okay. And then we're adding those two. Why would that be here though? That's also weird. Like this is whether it's over the exit or not. Okay, in case that means, yeah, but like why is that assignment here? In case that means like exit level or something. So this is all behind 627C, right? That was quite complex. Let's just remove that one and see what happens. So we already removed skull targeting AI, and that indeed stopped them from moving. Let's remove this skull. This does a lot, but it might be, I mean, the collision detection didn't work either, right? When we removed the skull targeting AI, but I wonder what will happen if we remove this one. Okay, let's reset our ROM. Let's open the hex editor, again the wrong one. And let's find FD7702 CD7C62. How many times? Only once. Okay. Then CD7C62 is gone. And let's load the second level, right? With the skulls in them. The hacked level. Okay. Let's not break here. And let's see what happens. So the skulls. Okay, okay. Here we are. I'm going to disable this one. And see, so they are going to target me. Oh, there's no collision. Okay, now it's extra difficult. They don't care anymore about like it's pathfinding, but it's ignoring all the level itself, right? That makes it quite hard because they're gonna, yeah. So that still works. Like the collision with Lolo still works, but not with the field, like the playing field. Okay. Let's go back to our regular level. I think it was this 627C, or maybe, yeah. So I thought it was collision detection with the AI slot enemy, but it is collision detection with the environment, right? Which is this function, what we have to get out of this function. No, I probably had it up there still. I think it was this one. No, not at all. So this one remove, let's look, remove. And this one maybe. Yeah, here. So 627C is, I wonder if it's only for skulls. I mean, that's the only thing that moves around. So yeah, it's going to be for skulls only. So let's add that one. Skull, wait, well, it's not just walls and blocks, of course. With environment, yeah. Okay. Good. Reload that. Do we have another function here? def1ec. Oh, that's interesting because that gets written into our collision though. So let's look at that one. d1ec. Well, no, that's going to be that. Yeah, that's going to be the calculated collision collision element D1EE. So these two guys. Yeah, so these two are copied over into these two. I don't know why that is, but D1E, C, and D probably as well. So they are collision related, but I mean we can look at 5FA2 of course, because that's going to do probably something with that. Let's go in here. Okay, so it loads 7171, this one here. Let's see what it does. D into A, that's our 71, yes. Okay, we're ANDing it, we're comparing it. So, yeah, this compares a whole load of stuff. Okay. Okay. Let's continue. And I think we're looping our skulls here. Yes. Okay, there's only 2 skulls, so that's fine. Apparently not. That's weird. So let's see what gets loaded into A though. I don't know, now we're done. And remove entity from map. Right, that's going to be the background, I think. Because sometimes it overlaps. When it overlaps, it doesn't clean up the background, and I think that's this function. Then IY is D048. Let's look at that. That's this one. That's again our skull 2. Taking the direction, I guess, +2, which is 5. Yeah, that makes sense. Ooh, we're calling lots of stuff again. Okay, so let's first look at our game loop and see what we had there, right? So let's escape here. Where are we here? Oh, we were in that one. That's weird. Yeah, so we were in 5B79, right? It's going to be hard putting a name on this one because I don't know what all it, like what else it does. 5B79. So if you look, 5B79 starts here. It does the skull targeting and the collision. So I'm going to reduce it to that, but it does more though. Yeah. Here's my game loop. Five B79. Nothing in 5B. Five B79. Okay. Then 59A6. Oh, this is ALMA handling. We check whether there are ALMAs in the level. So I'm going to immediately, because we're doing the same thing here, this is going to be the ALMA handling, targeting and collision detection. Yeah, remove, and this is going to be the same thing. So let's just remove it and see what they do. Back to the game loop. Okay. Okay, twice. We're going to remove both. We're going to load a level with a hacked level with ALMAs. And let's see. Okay, they do still target me. Wait, let's check if I remove the correct function though. I did. They respect the... Yeah, so that all works though, that's weird. Oh, it doesn't... Oh, is it the rolling? It's the rolling. Wait, but did we not have... Yeah, handle low movement though. No, sorry, ALMA, it's ALMA. Do you not have... Yeah, we have ALMA AI horizontal vertical rolling. That is weird, and if I walk into it... No, I can't walk into it. That is very weird. Yeah, once it starts, when it wants to roll, it doesn't. But if I let it touch me, well, that's going to stop it too, of course. That's super weird. Or is it simply the Lola collision? No, it's not a Lola collision. Yeah, so that still works. Right, I'm going to have to go to the construction mode and see if I can get it to roll vertically. Yeah, let's just start here. Let's see, I'm going to add a hard framer, of course. Okay, let's see if it starts rolling vertically. So it doesn't roll, but it doesn't stop either though. Okay, I need to escape because, okay. No, okay. I need to put one in on the other side. Because it stopped when it tried to roll horizontally, and vertically it doesn't roll at all. Yeah, this one completely stops. So it's a horizontal thing. And can I re-trigger it? No, I cannot. That is weird. Now, the other weird part is the fact that I already had a function that handles the rolling. Wait, where are we? Like, let's load the normal level 5. And let's look at the game loop again. Like, we have a function here that does this one, horizontal and vertical rolling. Right, so it checks bonus level around started, that's fine. The amount of almas has to be more than 1 or more than 0. It checks Lolo's position, X and Y. Wait, so it does 3 and 7 here. What is 4382? Okay, it calls 438C twice. Okay. Four three eight C. Wait, was I mistaken about the number here? Okay, this is calls from many places, that's why. Are we here? No. I have to go back to the original function. So yeah, vertical and horizontal rolling does this 4382. So that does it 6 times, right? So twice for this one, then another 2, which is 4, and then as 8 times, it increases IY. Okay, let's go one back. Wait, okay, I lost my place again. So this one here, IY is D082, which is the first ALMA. And so it's going to affect IY, right? So we're going to step over. It goes from O2 to AA. Does that make sense? Yeah, that's from 2 to 10, which is 8 difference. Are these 8 wide? So we have almas 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So that's okay, sure. It's just the length of the array. It's a very weird thing of like a very weird way of incrementing IY by 8, but sure. I guess you can increment it by 8, increment it by 6, 4, and then 2, right? 4, 3, 8, 2. Two, 2, and then this one as well. So yeah, we can do 8, 4, 8, 4, 6, and 2. Okay, so that's merely next ALMA, I guess. D132. Oh, that's the X dates that was updated here. Okay, so that's, oh yeah, of course, at the end of the loop, we are incrementing our pointer to the next ALMA as well as the next X state. It would be handy if I can put comments in this disassembly though. So let's loop through this function though. So let's start here. Okay, ALMA's positions and X states, sure. IX is D131, that's going to be the first ALMA. D131, yeah, that's X state. Oh yeah, it checks X state, otherwise it ignores it, that makes sense. Sure. And then it loads Lola's position Y. and it compares it to IY, which is DO82, which is the ALMA first, well, the current ALMA Y position, and it jumps. Well, it's not going to be for any of them because they're not on my exact Y position. Okay, and we're going to the next loop, so we're going to do that 3 times. Right, for none of the 3 it will match. All right, okay, and we're off again and we return. Okay, so next step. Okay, they all go up, so it's not going to match either. Yeah, now it will. Now it, well, they are on the same Y position, but they're not gonna roll, I guess. So yeah, this not gonna jump now. Well, it is though. Why? The X position is the same, not Y position. Right. Oh, so it doesn't check both though, because it checks Y position first, and then it checks X position. Let me get into the same Y position. Okay, so I'm gonna disable, wait, I'm gonna remove this one and disable this one. Yeah, I need to be at the same horizontal level as an ALMA. Okay, yes, on this side. And okay, I'm going to break after this jump, which will happen, I think, when he moves 1 up. Yes. What do we do then? IY is DO82, which is the first ALMA. DO82, we're loading +7. So +1, 2, 3, 4, 5, 6, 7, which is this roll direction. We're checking whether it's 0. Okay, are we rolling? Okay. If it's not, we're not rolling, we're jumping to 599D, which we're going to do. No, we're doing not. Okay. Right. And then, only then, so this is only horizontal rolling. Okay, so then we're checking Lolo's X position. Compare that to Alma's X position. Sure. We're loading 3 in the accumulator either way. And we are, depending on the X position result check, or check result, we are jumping, which we don't do. Now we're loading 7. Oh, right. It's determining whether it has to go left or right. So it starts with right, which is 3, right? Three is right. Yeah. And then so it's left because it has to go left. That makes sense. So this does only horizontal rolling then. So yeah, and then we're putting 7 into our ALMA rolling direction, which is this one. Okay, we've done that. And we're going to the next one. So this up, but it's only horizontal then, right? Or wait, can we? Yeah, because the first check is whether we're on the same Y position. And I think Rollo also, ALMA also rolls when matching vertical positions, right? Or is that not the case? Okay, but that's for sure everything that function does is it checks are we on the same Y position. If so, check whether he's left or right and update the direction, the rolling direction in that direction. All right. And I named that function horizontal or vertical rolling. So that's not correct. Update rolling direction if Y pause. I mean, that's just a long explanation here. Oh, hi Kim. There you are. Yeah, so how I'm going to... Well, I'm revisiting some stuff that I wrote before because there was like a conflict with... like I'm seeing the same thing twice, a couple functions down, and that doesn't make sense. So I have to revisit what I did before and confirm that it did what I think it thought it did. So yeah, it's a bit complex now. So that function, it updates the rolling direction for horizontal rolling based on Lolo's Y and X position. Well, Y position. I mean, update horizontal rolling the direction, I guess. The fact that it's based on Lolo's position is implied, of course. Yeah. So now the question is, does it roll vertically? I forgot about that. So let's make it, let's see first, right, whether we can make it roll. Yeah, no, they don't roll. I don't think they do. To confirm, I have to go in construction mode and see whether they are actually rolling vertically. Stop. So if I create an empty level with just, well, the same thing as before, right? So I'm going to put just Lolo and then the exit, sure, and then I'm going to put one Alma at the top here, and we'll see if it just walks down or rolls down. And it walks down, so it only rolls horizontally. That does make sense then. Okay, so that function is for sure horizontal rolling direction check. That's confirmed. Right, so update horizontal rolling direction. But then this one, the weird one is... like it looks like collision detection, but only horizontally. 5986. I'm gonna disable it again though. So I think I still have that. Let's look what I commented out. Yeah, so this one is gone now. Let's see. So it stops when I am on the same Y level. I mean, it's very hard to get these things to do what you want. Yeah, I mean, working is relative here because I still don't know what the new function, the function I was actually investigating, what that one does though. So I've removed that one now, and the problem is going to be determining exactly what that does when that function doesn't exist. Okay, so it's going to attack me. That's fine. That should work. Yeah, so that works fine, right? Now the question is, okay, I can't move over the exit, of course. Okay, now it goes to the next level. Should have put the exit on the right side. Because I have to move to the right. I might have to change the field though, because I'm not sure. Yeah, it's going to go to the right, of course, and then down again. I need to be on this. No, I need to be horizontal. Yeah, so we have to put them here, I guess. Okay, let's see if he rolls at all, which he should, because that's a different function, right? That's the original function we were looking at. Right, it doesn't roll at all, and he blocks immediately. Wait, so in the original function, we just assigned the direction in his array here, right? This little value here, the roll direction. It still has to do it though. Like he still has to actually roll, and I think that might that might be that function. Yeah. I mean, it would be normal to check the roll direction at the start of that function to see whether he actually has to roll. Wait, let me reset to the normal ROM. Actually, I mean, I do need this construction mode though. Let me get into construction mode. And I'm going to remove this one too. It's going to immediately start rolling then, but that's fine. No, we need, we need horizontal rolling. Okay, let's see. Oops. I mean, I can't escape though. I need some space. I mean, these can go too. Let's just put the exits at the bottom here, out of the way. And now let's look at our game loop at this function here, 59A6. Right, it checks the amounts of almas and immediately goes to its positions and states. Let's refresh here. No clue. Okay, let's see. It immediately stops, which makes sense, but the level hasn't started yet, so yeah, I don't understand either. OC, wait, that seems to be like a state or something, right? We're writing OC in D1FE. D1FE, that's like this one. That's being written. And then we get the X state. That's irrelevant. IY is D082, which would be the first ALMA, I guess. D082. Yeah, that's the first ALMA. And we're taking the direction. And we're writing that in D218. Okay, now it's back. We're writing that in D218, okay. We're loading the OIX is D131, which is X state, I think. Yeah, that's X state. Oh, we're checking whether that's 0. Sure, that's irrelevant. Now we're going +7. Okay, so IY is again D082, which is the first ALMA. 1, 2, 3, 4, 5, 6, 7 is roll direction. Excellent. Yeah, so yes, okay. This function indeed only checks things when the roll direction isn't 0, which is important. And this is going to jump, I think. Yes. And we are, okay, we're going to the next ALMA. D1FE. That's the OC, sure. Oh, C is, well, no, it was 10, right? That's A. So we're loading D1FE into HL, okay. And we're increasing that by 2, DE. And we're, okay. And we're writing A, which is 0, back into D212. Okay. And we return. Okay, so we're not in a state where there is an ALMA with an assigned rolling direction. Because if we go look at the first ALMA here, we have X and Y. But if we go down here, we see that the roll direction is 0. So that hasn't happened yet. I'm going to have to conditionally stop this breakpoint and then start a level, and then it will have a roll direction. Yes, it does now. So now it's rolling to the left, and let's break here. Okay, so we're in our function. We're doing the same checks, right? So there are ALMAs in the level. The Y position is loaded. We're writing OC for some reason in that D1FE variable again. Check the X state. Now we're checking IY was ALMA's direction. So this is his direction, which we are writing into D218. Okay. So D218 is the current rolling direction, I guess. Sure. And then that's the, well, no, that was the current direction, and this is the current rolling direction. Now we're checking whether it's 0, which it is not, so we don't jump. Okay. Oh, and now we have to handle it. It's weird though, so why would there be two different AI collision detection functions, like ALMA Lolo collisions, one for rolling and one for regular interaction, right? Like regular movement. That's a bit weird. Because now we're actually loading this ALMA into its AI slot, unless this is the code that does the rolling until it detects a wall or block it can't penetrate. we're writing something in DO82, which is the ALMA array at position. Oh, that's the direction. Okay, sure. 7, we're writing 7, so we're overwriting our current direction with the rolling direction, sure. And then we're loading these this data into the AI slot, which is over here, okay? So we're loading the coordinates and the direction. So these 3 values will change, I guess. Let's see. Now, yes, 16, 29, and 7 stays 7. Okay, we're loading 1 into A, and then D2 on 2. Oh, this one becomes 1. Okay. We're putting C4 into... Oh, this might be the unknown. Wait, let's see. So we are here. This is the first one. 5 positions. 1, 2, 3, 4, 5. Yes, this is our unknown. We don't know what this variable means, right? So we're putting C4 in there. Okay. And we're putting the X coordinates into A. Okay, that makes sense because we have to look at the ALMA's X position to see if we hit something. Yeah, we're ending it with 1. That makes sense. Oh no, that's checking whether it's odd or even. Sure, so we don't... Yeah, we jump because I think we only do hit detection on even positions. Is that true? I don't think so, no. I mean, we're not exiting the function here either though, so it's fine. So now we're loading 6C into IY plus 3, IY being DO82 again, so that's plus 3. Oh, that's the sprite index. 6C, which would be what? Let's see. That's going to be the Rolly thing, I guess. 108. Let's see what that is. No, not sprites. Wait, or is it a sprite? It could be a sprite. 108. Yeah, no, it's going to be the sprite because that's water. No, it is indeed sprite because I saw them appear in the sprite viewer. Like the thing is here, so 108 is going to be a rolling. Oh yeah, it's alternating the rolling things. Like there's 2 sprites to make it look like it's rolling, right? So it has to alternate between 104 and 108, which also makes sense. The way it does it is it checks whether we're on a odd or even position, and either odd gets one of the 2, right? That does make sense. Okay, 654F. Let's see what's in that one. Ooh, direction stuff again. Oh, right. So this is before a function we already had. So that's pretty much the same function though. So apply direction to AI slot. Oh, and instead of getting this as a parameter, this function loads it from IY, which is loading it from a mob position, like the 3rd position in that array. Okay. Okay, that makes sense. So this is the same function, but from an entity, like from the... So that gets it from... That gets the direction from the parameter to the function, this one here, and this one gets it from an entity. Okay, so a couple... Apply direction to AI slot position is still correct, but this gets an entity pointer or mob pointer or mob pointer. Let's put mob, and that's 654F. Okay, and then the updates X and Y of the AI slot. Wait, that's incorrect. Updates X and Y from the AI slot, depending on the direction given, depending on direction of mob pointer given. Okay, so that's pretty much a reused function, sure. Okay, so we escaped this one. So yeah, so it applies which direction we are rolling into onto the X and Y coordinates. So those have been updated, one to the left, or yeah, one position to the left. And then 4412 immediately calls 657A and increases HL 3 times. 657A does what? Oh, does mathematics. Okay, sure. So we're looking at D082, so that's the base pointer of the ALMA we're currently working in. Yeah, that's like 10 bytes of ALMA data. Okay. A057 into D009. Oh, that's also interesting. D009. Ooh. So what are we manipulating here? Oh, we just exchanged DE and HL though. Okay. So the calculation happens on, so we're loading HL into A, we're doing some additions, some decrements, okay. We're loading E, oh yeah, we're loading A into E, increasing, so we're doing stuff for the Y coordinate and we're doing stuff for the X coordinate, sure. Oh, okay, so we're loading both results into E and D, we exchange DE and HL, sure. And then we're loading HL, which is actually DE, into this D009 though. What was given as parameters to this function though? I can't remember. I think it's locations. Is it positions? Not sure about that. But yeah, we're saving something in D009 here. It's like a calculation based on, I think it was coordinates. No, well, we gave the base pointer, right? No. The HL was the base pointer of the ALMA data, and the first two, because we're incrementing here, is Y and X coordinate. So we're doing some sort of calculation on the Y and X coordinate, which might be a conversion from either a tile within from 0 to 22, or from 0 to 11 to 0 to 22 or something. I mean, 16, that's 22, and 29 is, well, let's look at the array here. I mean, it's 16 and 28, of course. So it's 22 and 40. I still have to figure out exactly how the coordinate system works, though. That's going to help tremendously. Because, yeah, these values are way higher. 209. And I don't think that's a tile or something. Yeah, no, that's definitely not a tile. Okay, so what do we do with D009 though? Let's look at that. So we'll exit this function. and we're increasing ALHL. So that's now DO82. What was that pointing? Okay, that's pointing to the start of the first ALMA. And we're going to the next one because we're adding, oh no, we're going to sprite index. Also interesting. So we're going to 5, DOA5, which is indeed the sprite index. Okay. And then we're loading D1FE, which is OC into A. It's getting complicated now. Then we're calling something again. Yeah, this is going to be a base to apply a tile to, I think. Let's see. We're doubling A and again adding or loading 0 into D, sure. A into E. Okay, so 1B00 is our base. And we're adding stuff again. Yeah, that makes sense. 1B30. Exchanging, popping, sure. And then that into H. Into A, sure. The value of, wait, DOA5. What's that? So we're indexing it into an array. DO8, no, DOA5. That's the sprite index. Okay. Which was 6C into D00B. Right, that's just after the ones we were looking at. Okay. Yes, 6C. 6C might be, let's look at, okay, that was the next Rolly, that was 108. That was the next Rolly thing, I think. 108. Yeah, that's the next tag we have to apply. And we're going to DOA6, which is the color, which we're going to put them in C. So, I mean, I'm going to add some names to this because this is going to be the next sprite. So Alma next sprite and Alma next color, I think. Yeah, because this was this 8, which is a sprite color. Like we might just apply these values to the AI slot. I don't know. It's complicated. Right, and then we're taking the pointer to these couple of values and we're calling something. So this is going to use that. Okay. That just calls a function. Okay. Yeah, now we're quite low. This is going to do something updating on the screen perhaps. Let's jump in there. Yeah, now we're quite low. This is outside of the ROM, I think. This might just update it on the screen perhaps. So I'm not gonna go, yeah, this outputs stuff to a port. Okay. It does it a couple times and returns. We go out of this function. So this is an update function simply, I think. Okay. We'll do some rotations. Let's see what this one does. Again, calling a very low function. That's fine. And we return. And for some reason we are done with this Alma, I think. Yeah, we're incrementing now. Okay. Again with these weird values, and we return. Huh. Oh, we're actually at the end of the function now. Wait, that's possible? Yeah, of course I broke in the second half of the game loop here, apparently, but that's fine. So I think it is horizontal, like Alma rolling horizontally collision detection, perhaps. And breaking, like collision with the environment and with Lolo, I assume. Okay, let's put that as a temporary name. $59A6. And then let's look at the next one, 5A65. We can remove these. 595. Wait, what was it? Crap. 5A65. Again with the Almas. So this might be a regular collision detection, perhaps. Let's see. It does stop here. Okay, it's the amount is saved. There's only one. We're loading the first Alma in IY, pointer to the array. OC goes in D1FE. I mean, that must mean like we're doing something with the Almas, right? And then one in D212. It checks it loads the X state, sure. It loads the first X state. Is it 0? It's not 0. It loads the rolling direction. That's +7. See if it's 0. If it's not rolling. Okay, so if we are rolling, we don't do anything here, perhaps. Yeah. So this is a regular. I think this is a regular collision detection. Because do we return here? Yes, we do. Yeah, this is the collision detection when we are not rolling, which would make sense that would be the next one. Okay, so let's disable that one and see if we can force it to like either roll over the entire map without any regard for blocks and walls. If it is in fact that. I forgot to put quotes here or parens. Okay, and then 5A65 we are going to knob out. Let's reset the ROM, get the hex editor, open the ROM, and find CD655A. And how many do we have? Only one. Okay. that's done. Let's open level 5 hacked. And let's continue. Okay, let's see if it will. Okay, now it's completely dead. Okay. And exactly, so those two are split up. That's very interesting. I mean, they're gone now. I don't know why, but now they're completely gone. Yeah, but so there's a separation between regular AI, like position detection, like targeting and stuff, when it's walking normally and when it's rolling. They split it up for some reason. I mean, it makes sense, right? Don't know why they don't appear from the start anymore, though. I guess there's a difference when you don't reload the level, or when you reload the level when you die, perhaps. Okay, so it's going to roll. It's going to come over the block, I think, and kill me. Yeah, of course, it can't do anything else than rolling. Okay, so that's simple then. I'm going to reset to the non-hacked ROM. And then this 6A, 5A65, 5A. That's going to be handle ALMA regular or non-rolling collision and targeting. I mean, non-rolling movement, right? Because we don't really know that the targeting is handled in that function. 5A65, so that's an easy one. And now 563B. Wait, 536B? Yeah, it was 536B, I guess. Okay, is it a bonus level? Has the round started? D1FC, again, one of those weird things at the back here. The round hasn't started, so it's going to exit here. Yeah, I need to start the round. Oh, let's break here. Okay. So oh, this is goal detection, or AI movement detection of player detection, I guess. Yeah, we're checking. So, this is interesting though, because this doesn't happen when D1FC is not 0. Oh, it doesn't happen. Okay. That's interesting because we can just check for goals in the level, right? Which it does after. So there's some variable that happens in levels with goals that D1FC is 1. That's cool. So let's load one. Let's deactivate you and start and get a level with a goal in it. Which is what? 3? Yeah. Start. Okay. Let's start the level and let's break. And this value is still 0. Does that mean that it has to be an exit state? Like, but that's another variable though. I'm going to force that value, see if I can force that value. Because yeah, we're going to exit here again. Yeah, okay. So I'm going to block or break after this one, when we check how many goals there are, of which there are 4 now. Okay, so let's see if I can force this. Yes, I can, but what does it do? So let me first see if it stays on 1. It does. Do they start shooting fireballs now? Yes, they do. It's weird that that is a separate variable, because that is the same as like game completed, as in all the hard framers picked up. So I don't know why they put that in a different variable. Now, question is, so yeah, let me pick that up. Wait, so I'm gonna put it on 0 again. So it's this one. So yeah, they stop. I mean, okay, there's a fireball mid shoot here, but that's fine. Does it set that to 1 when I finish the level here? It does. So there are multiple that indicate the same value, unless, no. Bonus, but yeah, bonus level is checked differently, right? So why would you have a level? So this one is the variable I'm talking about, exit or opened, meaning all the hard framers have been picked up. That's the amount of hard framers picked up, I think. Yeah, this should be amount. So there's no confusion, amount of hard framers left and amount of hard framers picked up. And then we have a variable that says, yes, the exit door is open, but then there's an identical one that says, yes, activate the goals, which I can't turn off anymore now, which is also interesting. So if I turn the exit door, which I can't do either, okay. Okay, I can do that if I force the amount of non-picked up hard framers to 0 or to 1. Okay, that's weird. So I wonder if that variable here, the one that starts with lava shooting, with projectile shooting, whether that's specifically for goals or if it's for something else as well. So let's see. I'm gonna put that, give that a name first. So D1FC, yeah, D1FC. Should goal start or shoot fireballs? Triggered when exit door is open, but separate variable. I mean, I could have used the same one. For some reason they didn't, but okay. So now let's see if that variable in a different level is also set. When one which doesn't have any goals present. Perhaps the second level. So let's reload our symbols. Okay, so now this one, yeah. So let's eat the last one. Okay, it's not set. That's very interesting. So apparently it does that conditionally based on the fact of are there goals in the level. Because if I put that on 1, that does nothing. Let's go to a bonus level, because in a bonus level the goals are not supposed to shoot fireballs either, but that condition is checked separately though. Right, so at the start of this function, where are we? Game loop. Okay, no, it was down here. 536p should still be in here. No, it isn't. 536p. So the first check we do is if it's a bonus level, we don't do anything. So we'll look at, oh, this is 1. Wait, let me start a level. Yeah, that is, oh, it could also indicate the state of, because they have their eyes open now, that could also indicate that state, although they didn't open their eyes when I put it on 1 though. Oh yeah, that's forced to 1. Okay. Good. So that's, I mean, I guess that only applies to goals. Then we check the amount of goals in a level. I mean, it is going to be the shooting of the fireballs though. I'm going to rename lava to fireball. Because yeah, this is fireball, not lava. We have an unknown here though, so we might as well look at this one. Let's go back to level 3 it was, I think. Yeah, this one. Let's make it shoot fireballs, and let's break in that function, which I've already forgotten. That was this one. Okay, so let's wait here. Okay, so we're loading the goal positions. No, I have to do the first one. That's easier, so I have to position myself here. Let's remove this one, disable this one, and because it's easier if I activate the first goal. The first goal is top left in the level, right? So that's easier here. Let's break. Okay, we load an unknown into IY, which is a 16-bit thing though. That's also interesting. Well, I mean, we do the address. So DODC. Yeah, that's this one. So we have YX, the fireball direction, sprite index and color, and then it might be like treated as a little separate array, but it's only one value. Okay. And we're calling something immediately. It was in IY, okay. We are loading this value immediately though. IY plus 0, okay. That would be the 2 that we saw. We AND it with FE. And put that in back into that position. And we're calling something again. Okay, that's by 6. I have to put that one there too. No, increment y by 8 is by 6 then. That's 8, 5. That's correct, right? So we're calling the by 2. So yeah, so this is 2, 4, 6, 8, and this is just 2, 4, so we're calling by 2, and then 4 more. Okay, that's by 6. Okay. Let's go back. And then we're looping to 535A, which is, we're looping every goal, I guess. 535A is here. Okay, so yeah, we incremented IY by 6. Does that make sense? We are at DOE2 now. So we were here for starters. 1, 2, 3, 4, 5, 6. Yeah, that's the next unknown. Okay, makes sense. So we're ANDing all these unknowns by FE. I mean, those are going to be 0, so that's fine. Wait, are they? Yeah, right. Oh no, there's no fireball on the thing though. There's no fireball on the screen, so let's maybe wait until we have one. Wait, are these fireballs though? Because there isn't one on the screen now though. Unless there's coming one out his mouth right now. I'm going to wait until there is one on the screen. Okay. So what do we have? Different values now. X direction, sprite color. Unknown is now 81. Okay, that looks like a either sprite. 129. Yeah, it might be a sprite. Oh, what is 129? No, it's odd. No, it can't be. Is it a tile then? No, not a sprite either. Not a tile either. Okay, so we're loading. The ODC, which is this one. Okay, that's the first one. Sure. So that's the correct one. That's this one. Let's go in. We're loading that in the accumulator and we're adding it with FE. So 81. Okay. Let's see. So X 81 and FE is 80. What is FE? That's okay. So we're making it even, right? So we're subtracting 1, I guess, which makes sense, right? If we're doing an AND with FE, everything stays the same except, yeah, we're rounding it down. Right, we're rounding it down. And so we are rounding this unknown down and putting it back where it was. So we're writing this 80 now back into the unknown variable. Right, okay. And then we're going into the next. So that's weird. So let's give that function a name though. What was it? 5357. Let's see. Yeah, 5357. Let's see, where are we? 53. Okay. 5357 is round down goal fireball unknown. Well, it's subtract 1, I guess, which is rounding down, right? Okay. And then we will load HL. So DO64, let's see where we are at. 64, that's going to be the Y position. Okay, so Y, X direction, I think. Well, it's a goal position, not fireball. Then, so we have X direction, and so we do 1, 2, 3. Okay, so we take Y, X, and direction in E, D, and C. Okay. And we take the X position of Lolo in the accumulator. Okay. And we're subtracting that with D, D being the X position of the goal. Why would we do that? Oh, that's the difference. Okay. Well, yeah, it makes sense, right? We're doing X of Lolo minus X of the fireball. Is it perhaps the collision sprite? That could be that, though. JR. I don't know what JR was. I mean, it's a conditional jump, non-carry, so it jumps based on the carry, which is 1, right? Let's see, just to be sure. And see at the value. Okay, that's this one. No, that's, yeah, JRNC. So if the carry flag is unset, the signed value is added to the PC. The jump is measured from the start. Okay, so if the carry flag is unset, D is added. So we are set, so we don't jump then, I guess. Oh, we do. Okay, so we skip this neg. Okay. The A has the difference between the two. We round it down to, or round it -2 or something. FC is how many? No, 1, 2. That's we're taking the lower 2 bits off. Sure. 1A becomes 18. Okay. F53FA is down here. That's this one. Oh, and we're checking Lolo Y's position. Okay, this is going to be collision with Lolo, I think. Okay. But this jump should, yeah, it's taken because it doesn't hit Lolo, and we're doing the same with the Y position, I think. Yeah, of course, subtracting now E, which was previously set to the fireball position Y coordinate. Okay. Again, same rounding, some sort of, and then also doesn't hit, or it doesn't hit, so we don't do anything, and then we, because 540D does what? It returns based on that result. Okay, never mind. And we continue the loop. I guess I'm gonna have to be hit now to make sense of this, because it's going to do the next goal now. Okay, let's get hit. I mean, I'm gonna have to trigger that specifically, or like, that's not gonna be easy. Yeah, it wasn't quick enough, but that doesn't matter. Let's just knob out the function and see if we can get hit. That will give us our answer too, of course. So let's go back to the game loop. And let's remove 536B. Let's overwrite our ROM and get the hex editor. Again, the wrong one. So yeah, let's see. We need to find CD6B53. We have 1 occurrence, that's good. Okay, that's gone. And now let's see what will happen if we load this level, but then without that function. Okay, let's go back to the game loop. Okay, that function is gone now, so let's finish the level. I'm going to actually put the block in front of the bottom right one so I can escape. Okay, do they shoot fireballs or not? They do not. Okay. So yeah, that was indeed the fireball logic then. Okay, makes sense. So let's return to the non-hacked ROM. Okay, back to the game loop. So 536B is simply handle goal well, it's fireball shooting and collision, I guess. Well, not necessarily collision. Handle, goal, fireball shooting. Well, yeah, that depends on whether Lolo is in front of the goal or not. 536B. Okay, let's reload that one. Yeah, then the next one is 52AC. Let's go into 52AC. That's another goal function. This might be the collision with the fireballs though. So we're going to immediately disable this function, stand in front of a fireball and see if it hits us, if it kills us. Yeah. That seems like the logical thing to do. Um, 52AC, so we have to remove this one. Let's load the ROM and search for CD AC52. Happens twice. Okay, so that's checked twice again. So I'm gonna remove them both. Okay. Let's load the same level in the hacked ROM. Let's put the block in front of him again in case I need to test more. So I wonder if I will be killed now by stepping in front of a fireball. So do they shoot fireballs? They do not. Oh, wait, let's see if I commented out the correct thing though. Yeah, so yeah, no, this is not correct then, because they don't shoot fireballs now either. And it does kill me though, which the previous one didn't do. So we do have to go into it, I guess. Let's go into the first one we were looking at before to see if we can find something else here. This one. And let's go back to our function. Wait, no, it's the previous one. We have to look at handle, goal, fireball shooting. This one, I guess. Right, it did some stuff with the unknown variable though. Like this can perhaps be the trigger, because we got killed when the second function was disabled. Yeah, that does make sense though. So I think this first function simply instantiates the fireball but doesn't move it, and the second one renders and moves it. I think that makes sense. Yeah, because I got killed when I touched it. So I think it exists, but it isn't on the screen yet. So let's look at the memory. So yeah, we're at goal fireball X MI. So this is the base of the fireballs, right? So yeah, amount of goal fireballs is probably set at the end of this function. amount of gold fireballs is loaded, it's incremented. And we are not writing that anywhere, unfortunately. Okay, let's look at this value though. And I'm gonna have to step in front of 1. Yeah, so that, yeah. So it incremented it to 1. So that's what that first function does, for sure. And then nothing happens with it, because that's what the second function does. It's also strange that we don't even have a direction though. Like, why would the first function not set that? I guess, well, it looks at the code it's connected to, but that's also not easy. Because yeah, how would it know that? I mean, I guess it is in the first position though. Yeah, because every goal has its own fireball struct, right? So yeah, that's how it links it to the appropriate goal, and it can look up the direction from that. So I'm going to say so that this function, yeah, this is going to be create goal fireball. Like, yeah, this is an instantiation function. And then the next one, okay, let me go back to the standard ROM. Level 3, okay. Yeah, 52AC. And this is going to be handle gold fireball AI. That does the movement and I think the collision detection. Yeah. Okay, 4BDC is the next. Let's see, 4BDC, where are we? Oh, Medusa, okay. This is going to be Medusa related, so let's just immediately cancel out that function. I'm going to remove this and this. I'm going to get into a, well, no, let's not get into a level yet. Disable this, continue, and get the ROM in the hex editor. We need to find CDDC4B. That appears twice. I'm going to remove both. Okay, and let's get a hacked level with Medusa in it, and I don't think that's going to kill me anymore. Yes, oh, it does, it does. That's interesting. Let's see if I remove the correct function though, because I have done that wrong in the past. Yeah, it looks like. Very interesting. So what happens if I move? Oh, it's opening the eyes when you're walking in front of them. Okay. So normally when I walk in front of a Medusa, it should open its eyes. Even though it can't hurt me, it should open its eyes. And I think it just does that. And then the next function is probably going to be the creation of the Medusa daggers and kill Lolo when that happens. Yeah. Okay, so let's double check by looking at the code. Level 4. Let's go back to the game loop. Let's look at 4BDC. Okay, so we check, are we in a bonus level? Does that mean that they don't open their eyes? I guess they always have their eyes open in a bonus level. Let me, yeah, this breakpoint, right? Okay. Let me check a bonus level. I think they always have their eyes open. Oh, no, they don't. I mean, that means I have to see, I mean, I have to play against the time here, but I wonder if they do open their eyes. Move. Oh, yeah, I could have checked vertically too, of course. I didn't need to go all the way down. Does he open his eyes? No, he doesn't. So I'm probably horizontally either. So yeah, in the bonus level, Medusa keeps his eyes closed all the time. Yes, good, makes sense. Let's go back to the actual level, level 4. And the function. Okay, let's break. I mean, I'm gonna have to move myself in front of the Medusa though, but sure. So we're not in a bonus level. We have Medusas in the level, okay. And then we load the Medusa positions and Lolo's position, or Lolo's, yeah, X and Y, sure. We're moving IY into HL. That's DO83. Oh, that's the value of IY. Okay, what's DO83? Okay, that's the pointer to the Medusa array. And we're loading the first one into HL, meaning 101A is the XY position of the first Medusa. Okay, we're loading C8 into C. C8, that can be a multiple of 22 or something. C8 is 200. Okay. And we're loading L, which is the X position. No, the Y position. Into A. Okay, so we're comparing, yeah, we're just subtracting the Y position of Medusa with the Y position of Lolo, I think. Lolo position Y is DO18. Yeah, that's OA. Yeah. So we're subtracting or taking the difference between Lolo's Y position and Medusa's Y position. And we're putting the result in E. And we're gonna, yeah, so that's not gonna be 0. That has to be 0, I think, for it to trigger. All right. So we jump. Okay, we're comparing it with 4. Okay. I think this is tile related because there are 4 tiles, like we can be on a half tile. And we're loading C4. C4 is going to be perhaps a sprite. No, it's not going to be a sprite. So what is C4 is 196. That's going to be Medusa, I think, 196. Yeah, that's the top with the closed eyes. right, 196 until, and now 4 left. 4 to the right, I mean, and then the OpenEyes is 200 and a bit more. Okay. So yeah, this updates it all the time, I guess. Like regardless of where you are, it always, or regardless of previous tile, it just updates it all the time. So we update C4, meaning closed eyes, in this state. Let's see what the next function does. I don't know. 438A. Oh, that's increment by 3. No, yeah, 3. I mean, I guess I can put them all in there. Yeah, because 6. We have 6. That makes sense. Like 2 and 4. We don't have 5 though, but that's fine, I guess. So 438A is increment by 3. Let's escape this function. Did that make sense? IY by 3. IY is D086. Let's see if that array is 3 bytes wide. D086. And I think it is. So we have a Y position, an X position, and direction. And that's everything for Medusas. So yeah, that is indeed increment by 3. And we get to the next Medusa. So now let's step in front of it. I mean, it does some math here to calculate the tile though. I mean, that's pretty irrelevant because we're not setting any weird memory locations. Yeah, so this is just eye opening depending on Lolo's Y position. Now, where does it handle the X position though? Because we do return here. Do we check X2? I guess they are both loaded. Oh yeah, no, they are both loaded. D and E are checked. So the Y position, otherwise the YX position, is loaded into DE, 16-bit value containing both X and Y, and then we're checking E and we're checking D. Right. Okay. So this is simply for BDC is checking whether the eye should open. For BDC, indeed. Okay, that's for BDC. Check if Medusa's eye should open. Okay, I clicked the wrong button. Okay. And then 4863 is probably going to be kill Lolo with the daggers if you walk in front of him. So let's quickly look. 4863. Okay, it doesn't load anything with Medusa. No, that's also interesting. So it's probably something else. Okay, 4863 was it? Let's see if we break there. This one can go away. What do we have here? Oh, D23B, unknown variable. 23B. No, this one. Oh yeah, that's that weird array that constantly changes. That's very interesting. Right, because if we go play here, that stuff changes like constantly. Like when I start a level, I mean, it doesn't change now, but I think when I move something, it might. No. Okay, so yeah, let's see if we can figure out what that does. Okay, D23B is loaded into DE. That's the address. Okay, the hard-coded value, and then the value of D234. So these are related. Okay, also unknown is loaded into A. That's the value. That's 0. We're ANDing it, so we're checking it, whether it's 0, and then 486F. So we might skip this one if it's non-zero. So I don't think we do. We don't indeed. We're loading 41E6 into DE. 41E6, that's a function pointer though. And then we're loading 23C0. 23C0 is also quite low. And we're calling something. Okay, so we have as parameters this value here, and then these hard-coded values. Okay, let's see what this one does. Ooh, load 0 into BC and call something, but it's the same thing though. 4897, that's this one here. Okay, depending on yeah, we'll probably end up here somewhere too. We're loading 0, 800 or 1000. And then we start here. Okay, let's go further. Oh, it already called. Okay, of course you have to call it. Oh, we're doing this a couple of times. Yeah. We're doing it for every 3 of these. Are these like memory regions or something? Let's see. So we have PC as 1000 now. Okay. Exchanging DE and HL. Fine. We're loading the value of HL 41E6. Wait, that's weird. Because is that a function pointer or 41? That's very high up. 41E6. For 1E6. Yeah, we're calling a very low function. This is going to be a function pointer. Because, yeah, for 1E6 is going to be... Yeah, this is... Well, it's also all B1s and stuff, though. This doesn't look like code, though. Let's look at it in the disassembly for 1E6. Oops. For 1E6. Yeah. This looks like hard-coded data in the ROM, though. Because it's all B1, B6, B1. This isn't code. That's interesting. Okay, so that's B1 then, right? Yeah, this one, B1. Yeah, and then we're exchanging. Okay, do it again. Call 4D. I have to look up what the BIOS functions are, right? Like 4D is going to be something known in MSX ROM. I don't know what it does. I mean, I can jump in, but yeah, it's going to jump to something else. It's going to call something else. I mean, I don't know what this does, but that's fine. We're increasing to 33C0. That's also that's even lower. 33C0. That also looks very weird. And we're looping. Very weird. Uh, 4863 was our main function, right? The one we're investigating. Yeah, it is. I mean, I guess we can disable that one, but that does like very low level stuff though. and it returns, so it does very little, but okay, let's see. That's interesting. So let's disable it. Let's reset our ROM. And we will find CD6348. Comes up 2 times, that's fine. I'm going to erase them both though. This might have big repercussions, not sure. I'm going to load the level 2, for example. Let's see what doesn't work anymore. I mean, this seems to work though. It might be Medusa related, but I doubt it. I can check next though. Yeah, that all seems to work. I can't walk through walls or anything. Yeah, they activate just fine. And let's see what the exit does. Works fine. Let's see if the goal works, if they shoot fireballs. Yep, looks like. Let's see, this one is Medusa, right? Yeah, let's see if these guys work. So they open their eyes. Can I get killed? I can. That's interesting. So we haven't figured out what this actually does. Did it read a value? I think it did, right? Oh, right, we're in the wrong ROM. Let's go here. For 863. Yeah, 23B is loaded. Right, that's that weird array. Right. Okay, that's score. That's the map, or another map. That's the water flow. Okay, yeah, these guys here. Now, I mean, they don't really do anything if I change these values. I think, like, they do alternate, but nothing seems to go wrong here. Although, no, I can still move. And these ones were related as well. These are immediately overwritten. Oh, that did something. That does something to the color though. That's strange. Not sure what that does. That's interesting, but never mind. Let's mark that as unknown though. Or yeah, we can just leave it. Then we load 1 into A and held false. Wait, do to A. Let's leave it here. held at false during game loop, maybe bar key processing. Okay. Oh, is this the movement handler? Because we haven't encountered that, right? Moving around can be barred by this 43C5. Okay, that immediately loads a couple functions here. We'll just, because it does check spacebar pressed, let's disable it and see if we can still move around. For no, 43C5 is this one. Okay, let's move it out. Okay, wrong one again. CDC543. Twice again. Okay, let's see if we can move around in the hacked ROM. I cannot. Yeah, this is handle keyboard input. I cannot do anything. Okay. I'm going to take a look into it though, but yeah, it's pretty certain that it does that. Let's load a normal ROM. Yeah, 43C5. Wait, I missed one. 4BTC. Yeah, the stupid S. That's because my keyboard repeat rate is too high, and it sometimes adds an S. Okay. Okay, so this is handle keyboard input. We are resetting that to 0, putting the key back to 0, key held back to 0, and then 568C. 568C, very small. Okay, this checks whether it's a bonus level though. Okay. And that's probably going to be the answer, what the difference is between the first set of functions and the second. So yeah, this does simply check whether it's a bonus level, right? So we're loading current bonus level in A. We're checking if it's 0. And we're returning if it's non-zero. I mean, if it's not a bonus level, then I guess I'd have to look up the instructions again. Oh, it goes for, oh. That's interesting. So yeah, if it's not a bonus level, it does check for fireball collisions. I thought it would have returned, but this is an unconditional return, of course. Yeah, no. Oh, and then it goes into the B-mode treasures function though. So this is B-mode related. Weird. Why is it combining bonus levels and gold fireball collisions and B-mode treasures? Wait, so okay, so oh, do we return now? Yeah, because we're not in B level, so it is B level related. I mean, these functions are used here though. Okay, so yeah, that's B mode related, fine. Then we check if we have to kill Lolo. The trigger is false. And we don't jump because we're not dead. And then it does the same thing though. That's weird. Like in the same game loop, it loops it calls those functions twice. Because we have egg pushing up here too, right? Is that because of the... It might be because of the half step thing though. So can we push an egg halfway? I mean, yeah, blocks we can though. Although, do we... Yeah, we cancel out the key here. So we're not holding a key anymore. I mean, I guess in their logic, that would be normal that you first process everything while the key is held and then do some extra checking when the key is not held anymore. Let's look at C6405, and that will be the last one. To check 6405 is floating on egg. Did we break? Yes, we did. And if we don't, we continue. Is position odd? Okay, so let's go into it, right? So we're checking if we're on an egg. Oh, it happens if he's not floating on an egg. Okay, we're loading his XY position. Is it odd? We have to be standing in a half position. Okay. 6405, so let's remove this one. Come on. Yeah, so let's disable this one and let's put ourselves in a half position. So we're not floating on an egg. Is position odd? Wait. Oh, did they have to both be odd, perhaps? Let's see. Yeah, I can do that there. No, let's go to another level where I have more space. Okay, let's move ourselves in a half position. Wait, so it's let's go in this corner. One there, one there. Wait, no, I can't do that. That's like in between, right? Yeah, I can't do that. This isn't the half position. This is an actual position. The half position is in between. So I have to break then. Okay, I have to break after this check. So this is something that happens only when Lolo's in between positions, like moving on its own. So yeah, let's see. And when I move now, yeah, so it stops when it's actually in a half position, when its little feet are in the air. Okay, current, so, oh, so is Lolo now in the AI position? That would be, so this is Lolo's position, right? Yeah. So this entire array is now copied in our current AI slot. So we're loading A, which is 03, which is the direction. Where does the direction come from though? Lolo is floating on egg, that's fine. We're loading Lolo's position. Does its position odd set A? I mean, that's the result of the function, right? Oh, that's here. Oh, we're right beneath that, okay. Load AHL into A, sure. No, where does that come from? That's weird. But never mind, I guess. So we're putting A in the current slot direction, which is 3. Okay. We're loading 1 and 8 and we're starting the level. Oh. Like, this is more like it's level running then, I guess. Yeah, they built it into, the ImGUI is indeed built into OpenMSX, but only in the GitHub version. It's not in the release version yet. So they used to have a separate debugger, and those two programs would communicate with each other. But now they built it into OpenMSX itself. It's pretty neat. I mean, it works quite well. So this start level is going to be is game running, I think. I don't know why this position is checked though. That's a bit. Well, this is the opcode sheet. It's a Z80, right? So it's like mainly this one. But yeah, there's lots of multiples, right? So I'm not sure about the exact number, but like this is the list. But it's not that many. Like if you look at the code, there's pretty much quite a limited set you have to know. And you can always look them up, right? I mean, I don't know them by heart for sure. But yeah. And it is from the 1980s, so I mean, quite complexity-wise, it's quite low. Yeah. I mean, it does get complex, of course, but once it gets deep into tall levels, then yeah. Okay, so we're putting 1 into, I mean, that's going to be is level running, I think. Let's look at that one. Start level is D25D. Right, this one is always overwritten with 1. So there, this is game running. Wait, so let's check to be certain whether that's the same condition when it's in the not yet started state. Yeah, it isn't. It isn't. Now it is 0 indeed. I'm pretty sure they didn't use a compiler. It was just written in assembly, I think. So I mean that makes it also easier. Of course, there's no optimization, so they would have written it like that, right? I'm not aware whether that exists for MSX, but yeah, that would be handy because now I have to like do it in my head. But yeah, I'm not sure if that exists. It would be handy to see what the equivalent C++ code or C code would look like. I mean, it's going to be C, right? But yeah, this is pure assembly. So so yeah, this one is kept low. And the moment I move, yeah, then it starts, right? So start level is game running. That makes a bit more sense, I guess. Yeah. Let's get back to the function. I mean, it can't be improved though. I have to move around a bit much. I need like favorites and like stuff I can move around better. I did add some stuff too, like for example these background colors. I did have to add that myself. Otherwise, like it wouldn't highlight the symbols that I defined in the symbol file. So that would just be white text on a black background. It's way easier if you can see which symbols you have defined. So I had to add that. I had to add a little button here to jump to the breakpoint position. Like that's some stuff that has to be added. But yeah. I mean, I've never done that, but yeah, that would be handy. Of course, I'd have to look into how to do that exactly, but that would be pretty cool because they are all. I mean, they're all patterns that come back, right? So it's not super hard to find like patterns in that. But yeah, I've never done that. Yeah. But yeah, it's combinations of instructions, right? Like you're loading stuff and then incrementing stuff. Like Yeah, I'll have to look into that because it would help. I mean, you can then literally just look at like C code or something, or like an intermediate. That would help a lot. But it also, I mean, this is also fun, of course, to try to figure it out just by looking at the assembly. But yeah. Oh, so we do jump, okay. Good. So let's run and then jump. 5F10. Okay, we're loading our positions, XY into HL, and applying it to the AI direction. Okay, that's over here. That's this one. And then 6 for this, yeah, function pointer again, of course. 6 for FB. I'm not sure what that will be, but let's look what gets called here. 6498, so FB was in there too, right? Wait, is this movement though? Like, we already had a function for that though. Right, this might be Lolo's movement, actual movement. So yeah, I think that's what that's going to be. Wait, let me comment that out, and I think that will prevent us from moving as well. So we have our movement function here, which is actually keyboard input, but this one might be updating Lolo's position based on the movement. 6405, let's see. Let's overwrite our ROM. Let's get the hex editor. CD0564. One occurrence. Okay, let's remove that. Let's see. I'm gonna disable that's disabled. Okay, and we load the hacked ROM. Okay, it's definitely something to do with the update here because it's flickering. Right, so that's, and it's way slower too. Yeah, this is an update function or something. My goals aren't working. Did I forget? No, I overwrote them. That's also weird. Why would they not show up? That's strange. Like there should be fireballs coming out and I should be dead now. And that's the only thing I removed right here. That's weird. So let's go look at the game loop again. Yeah, I only did this one. That's the only one that was removed. Like this influences Alma, goal. I mean fireballs. Let's see if it influences other levels, other enemies. No, I want not one. I want this one before the last one. Okay, let's see. So they move around. Do they still kill me though? I mean, move. Okay, and I can move over half tiles now. Yeah, they do kill me. Wait, does it let me move over half tiles? That's weird. Yeah, that's strange. Like if it's one over it and only on the right side. Crazy. So yeah, I'm not sure exactly what that function does immediately, but that's fine. We have most of them anyway. Let's load the normal ROM. Okay. What do we have left? We have one here, like there's a couple left because here it ends, right? So are we doing a keyboard input at the end too? That's also weird. Okay, let's look at 5C30. This might be skull stuff. Okay. We have an unknown variable here, D1FA. Again, in our, yeah, these two guys again. Not sure what they do. So this happens. This happens when the exit door, well, when it starts running the mobs. So that's no, that's not going to trigger now, right? I go on because we haven't finished the level. Yeah. So let's finish the level. There have to be skulls, so it's skull related. Okay. So let's load the one before finishing this level and then finish it. Okay, so it starts when the actual movement starts, which is this one, right? AI started. Okay, we immediately load something with 5 and 2. 652F, let's see. Okay, D009, that's this one. Oh yeah, we've seen this one though. I didn't give it a name because I thought it was reused for other stuff. I should have given it a name. So we're loading the value D1 into a value of H. So we're overwriting that with D1 again. Okay, as it is now. 6543. That's like a callback, I guess. Well, it is. They are knobs, but yeah. This is. I haven't figured out what these set of variables do because we're again here in this area. Okay, let's exit this one. We are looping apparently. Yes. Okay, so we are looping 5 times then. There's only 2 skulls, so what could be looping 5 times? Well, we're doing it per 2 though, because we are looping 8 twice. Wait, no. Right, so this is the last time. Wait, did we escape already? Yeah, we escaped already, crap. Yeah, I didn't see. Yeah, we're doing this 5 times though. That's also weird. And then D1FA is also, that's again, this one at the end here. Stuff we don't know yet. These two, which we're adding by 1, sure. IY is D11D. This is skull related. Yeah, there's the X date. Okay. We are checking whether we are in X state. Do not jump. Okay, so we're loading the skull into the AI slot. Right. DO45 is going to be the skull data. Yeah, skull 1 position. Okay. And we're updating the tile. Is this, oh, did we have a function for skull pathfinding? I don't think so. We have the activation, we have targeting, but maybe this is movement. So if I cancel this one out, it might stop moving the skulls around. 5C3A is going to be in this one, right? 5C30. Yeah, that's this function. Okay, we'll disable that one, and that's going to be it. 5C3A. Okay, 5C30, sure. CD35C, one occurrence. We'll get a hacked. Okay, I have to play the level, that's fine. So yeah, this might be skull movement. We did the targeting and collision detection already, I think. But if they stay still now, then that would be that. They do not. Okay, but it's very confused now. Okay. So we'll have to look into this function, but we'll do that next time. All right. I have to go eat. So thanks for watching. Maybe tonight, otherwise it'll be tomorrow. Okay. Thank you.